In this session, we select the safety valves. After this video, you will know how to select safety valves according to the latest standard, specify selection requirements, generate details for the installation, change your calculation if any issues are observed, generate a report. Let's start by selecting a new subproject. Here is an overview of different products. Let us select safety valves. There are a few important points here. First of all, this calculation is made according to the European standard EN 13136/2013, which is the latest version. It is important to look into these requirements as they differ from the previous ones. We will be looking at the calculation where a safety valve releases into the atmosphere, and we will be looking at a safety valve for ammonia. In case where the valve is releasing into the atmosphere, our back pressure is 1 bar absolute. We need to specify the requirements for the valve. 3 different options are available. We can specify the vessel it has to protect, or if we have to protect the compressor, we can do so, or if we have specific mass flow requirements. For this example, we will select first option, a safety valve to protect a vessel. Let's look into details. We have the safety valve here, which is put on a changeover valve, which is, in turn, connected to the vessel. We need to define the requirements for the vessel. Also, in this case, 3 options are available. We can specify the diameter, or the length of the traditional vessel. Or if it is a heat exchanger, we have other parameters, or simply the external surface of the product. Let us stick to the cylindrical vessel, and we will put in a vessel with a diameter of 1.5 meters and a length of 5 meters. So when we have done that, we need to go up and specify the set pressure of the vessel and put that to 20 bar. The program shows SFA 15 plus a DSV 1. This is the most common safety valve, but if we want to look at the other safety valves, we can use the drop-down menu. Now we have the result of the calculation. We have the relieving pressure, which is the set pressure plus the back pressure, and this pressure is an absolute pressure. We have calculated the required capacity of the safety valve, which is 915 kilograms per hour, and the valve we have selected has a capacity of 1500 kilograms per hour, which is more than we need. But according to the standard, we can downsize or reduce this capacity by 25%. So we can go down to 1200 kilograms per hour, and this figure is used to calculate the pressure drop. In principle, if we just have to select the safety valve, we now have everything needed. Let's generate the report. We have the operation condition, and we have a specification of the vessel and the performance data. However, very often a customer would also like to know how to install the safety valve, and this information is easily available in Coolselector as well. If we add a check mark here, we will get a calculation for the piping from the vessel up to the changeover valve. It is suggested 1 meter and same diameter as the valve, and here 1 bend is suggested, but in this case we just don't have any bends. We also have the connection type to the vessel. Here we have 2 different possibilities we can choose from according to the standard. They will affect the pressure drop calculation a little bit. And now we have chosen this pipe, and we can see that the inlet pressure drop is 0.335 bar, which is 1.5% of the set pressure, and this is fine according to the standard. More critical is the outlet pressure. So now we choose the outlet pressure, and you can immediately see all the results turn red, meaning there is an issue. If we look at the outlet, pressure loss is 10.5%, and maximum is 10%. Something has to be done. The first thing we can see here is that this is only a length of 1 meter, but it is in the same diameter as the outlet of the safety valve. So we need to enlarge the diameter. If we go 1 size up, the issue is solved. We have a steep output of 1 bend, but probably this is not sufficient. Just look at the drawing. So I put 4 in, but still we increased the pressure drop. However, it is okay. Let us stop here and generate the report. The report is now extended with the data for the inlet piping and outlet piping. All the documentation needed for our installation is available. If we are looking at a very big system, very often it would be sufficient to put more outlet piping together in 1 common outlet pipe. This is simple to do here. Just go up and press copy, and suddenly we have vessel number 1 and a copy of vessel number 1. Also at the left side, we now get the information on a common outlet pipe. Up to now, in the first calculation, we made a safety valve and 1 meter pipe. Now we will calculate a common outlet pipe, the blue one here, but you can see we have generated a problem. The pressure loss is now 19%, and we only have 1 meter. We need to enlarge that pipe. We can try 2 dimensions down. So now we have 7.2%, but we only have 1 meter. So let us assume that we need 5 meters, and let us see what happens. With a 5 meter of common pipe, everything looks okay. We have a total pressure drop of 9.1%, so that is perfect. So now we can take a look at our report again. Once again, it is extended with more information on a common outlet pipe. We have a pressure up in this pipe. The length and the diameter and the vessel number 1 data, and for vessel number 2 or the vessel copy number 1. This concludes the session on selection of the safety valves. Stay tuned for other tutorials on Coolselector.